Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question, which is insert, delete and get random in order of one, right? So this, what we need to do is we need to implement the randomized set class. So basically we're given a class, and in that we're given three different functions, three different methods, and we have to implement these things. I'm sure that you have, gone through the question. Let me explain this question in an easy way. So guys, now I'm going to explain the question. In this question, we are given a class which is called randomized set, and in this class, we are given three methods, and these three methods are not implemented by them. We have to implement these things. What they asked is, initially we have a insert function. And in this insert function, we'll be passing a value. If the value is already present in the set, we need to return false. But the insert, if the insert element is successful, then we need to return true, right? And then we have a remove method. In this remove method, the value is present, then remove it and return true. Is return true. And if the value is not present, we need to return false. And this is the most important method we need to take care of. This method is get random. We just need suppose we have a list of elements. From those list of elements, we need to return a random value, right? Each and every element must have equal probability. What is meant by equal probability? Let's look at what is meant by equal probability later. It is basically, it's like right to equality for each and every element. So right now, I'll explain you with an example. Okay, let's look at what is meant by equal probability. When the get random method is called, each and every element has the, must have the same probability to be returned, right? So in this situation, we can use the random method. We cannot simply return this element every time, right? So if we return this element two times instead of returning these things, this element will have more probability, right? So we should not do that. We need to return a random element. That means each and every element must be considered equally. Suppose it's like a let's assume it's like a job market, and someone comes and I need a candidate. Each and every candidate must have the same probability, right, to be returned. So that is what we need to do in this method. We need to return a random element from the set of elements that we have. So let's try to think how we can solve this. Okay, if the main important thing in this question is the time complexity. We need to perform each and every action in in these methods in order of one. Order of one means we cannot use any sort of loops, no loops, right? If you use loops, our time complexity will be more than order of one, right? So we cannot use loops. So we can only do it in a constant time, right? So let's try to analyze what we can do. Initially, if you look at this insert function, we need to insert it in order of one, right? And if you look at this remove function, we need to remove it in order of one. And if you look at this get random function, we need to return the random element from the list of elements in order of one. So when we see the time complexity of order of one, the only thing that we get into our mind is hash set. Hash set, right? Or hash set or hash map. Only these two data structures are capable of doing these sort of operations in order of one, right? So the answer should be between these two, right? So let's go with hash set. Since it is the first thing that came into our mind, let's go with hash set. What this hash set does is, its insertion time, its deletion time, and in order to look if a element is present in the set or not, everything will be order of one, right? So it makes use of hashing in order to do this. So let's try to solve this method by using hash set, right? So what we'll do is, you know, we are given a value and we'll check if the value is present in the set or not. It will take order of one, right? So we'll check and we'll insert element. Suppose I have inserted 1. So it will take only order of 1, right? So this thing is solved, right? This part of the question has been solved. And let's go to this part of the question. This part of the question we just need to, if someone gave us to remove 2, since we are not having any 2 in this set, we're not going to remove it, right? How are we going to see in this set whether 2 is present or not? Hash set has a method called, contains, right? If it is in the set, we need to remove it, and if it is not in the set, we just need to return false. If it is not present, we need to return false. So this can also be achieved by using hash set, right? So let's try to solve this thing. Now, what Uh, we need to return. Suppose we have a list of a set of elements 3, 4, 5. We cannot have duplicate elements, right? If you have duplicate elements, the probability of getting 5 is more than the probability of getting 1, right? Because 1 is only occurring one time and 5 is occurring 2 times, right? So we can only have unique elements, and the set only supports unique elements as well. And let's try to get a random element from this thing. Is there any way? We know that sets are unordered, right? Unordered. So we cannot access them with the help of indexes, right? So we cannot do this because sets are unordered. But then when there is no index, how can we access a random element? There is no way if we want to access 3, either we have to have an index in order to access it in order of 1. Either we have to have the index or we need to traverse sequentially from 1 to 2 and to 3, right? This will take order of n, right? So there is no point in traversing the entire set. So we definitely need to have a index. In order to have an index, we need an array, right? Only array supports random access, right? So let's assume we have an array 1, 2, 3, 4, and 5. Let's assume this index is 0, 1, 2, 3, and 4. So we can access this any element, let's suppose it is 2. We can access it with the help of the index 1. We can access this with the help of index 3. So we can do it in order of 1, right? So we see that, we can do the top two things by using the set, and we can do the last thing by using the array. But when you are updating this set, we also need to update this array, right? So when we are inserting an element into the set, suppose if I insert 6, I will also insert the same element. Wait, I will also insert the same element into my array list, right? So let's suppose I'm removing an element 6, the same element that I inserted. I can easily remove it in order of 1 in this set. I can also remove it in order of 1 from this list because it's in the end of the array, right? Because I can just reduce my size of the list, and I can say that I have successfully removed this element. But what if we are removing the element 3? We can remove the middle element as well in order of 1 in hash set, but how are we going to remove this element which is in the middle from a list? In order to remove an element which is in the middle, what we need to do is we need to remove this thing and shift all these elements towards the left in an array, right? So it will take order of n, right? So presently where we are at means, we see that these two operations are successfully solved by hash set, and this thing is solved by array, right? So we need to make sure that these two operations are also capable of these two are operations also update array as well, right? So we see that insert can be inserted at the end of the array in order of one, right? So insert is also done with the array, and we need to take care of the remove, right? If the element which is removed is on the end, we can easily remove it in order of one. But what if we are removing an element which is in the middle? So then what we need to do is we need to have the index of this element in order to remove this, right? In order to identify that it is in this position. So how are we going to have the index? So for that, what we need to do is instead of using hash set, what we need to do is we need to use hash map. What this hash map does is it makes sure that it says that one, this element is present in index 0. So for 1, we have a value called index 0. This will be the value, and this will be the index which is present in the array. And for value 2, it is present in index 1, right? So this will be mapped to this thing, and this will be mapped to this thing. So when we are trying to remove this element, we'll go to the hash map directly, and we see that it is present in index 2, and we'll go to the index 2. And can we remove directly from the index 2? We cannot, right? When if we just make this element as 0 or something, we cannot do that because the value is in the range from minus 2 power 31 to 2 power 31. So 0 is also included in the range. So when you make this value as 0, and when you call the random function again, and you'll come to this thing and you'll return 0, right? So it should not happen. So what you'll do is instead of filling 0, we have in an array we have only one option, right? In order to remove an element in order of 1, we can only do it from the last, right? So what I'll do is I'll swap these two. And 6 will come here, and 3 will come here, and I can successfully remove this in order of 1, right? So this is how we're going to do this. Suppose let's try to solve this thing. Suppose initially we're given a randomized set, right? So we'll be initializing our hash map and our list initially for this thing. Then we'll come here and we see insert 1. In the set we can insert in order of 1, and in the list as well we can insert in order of 1. And we are given a remove of 2, right? Since 2 is not present, we are not going to remove anything, and we are given insert 2. So we'll be inserting in order of 1 and inserting in order of 1 in the list as well. And now we're having get random, right? So when we are having get random, what we'll do is we'll take the length of the list, and the length of the list is 2, right? From 0 to 2, we'll generate a value between these values. I'm sorry, 0 to 1, only 0 to 1. We need to generate a random value between these two, and we need to return that thing. And when we come to remove, they're asking us to remove 1, right? So I can easily remove this from here, right? Now actually we're having a hash map, right? So 1 is at index 0 and 2 is at index 1. So I can easily remove it from hash map, but how can I remove it from here? What I'll do is I'll ask the hash map where is the value 1. It says it is in 0th location. So what I'll do is I'll swap these two the the value with the last element. The last element is 2, right? So I'll swap these two. Then it will become 2 and 1. So since this is at the end of the array, I'll just remove this. I'll just remove this in order of 1, right? Right now I'm only having 2 in my array and 2 in my hash map. I'm only having 2 in my hash map, which is at index 0, right? Wait. So if you observe carefully, we also need to update the hash map when we are swapping, right? So and again we'll come here and we're given to insert 2, right? But we're not going to insert since 2 is already present in the set. We'll just return false because we're not inserting, right? So again get random. When they are calling get random, we have only one element and we're going to return this element. So let's try to code this now. So let's try to code this. Initially we'll be having a hash map of here, comma here. So here we're creating a hash map and then we're also creating a list, right? Here list equal array list. And then when I'm sorry, we just need to declare these things and we'll be initializing these things here, right? Map equals to and list equals to. When we are calling the constructor, we're just creating the objects of these two data structures, right? And then insert, right? What we need to do in insert? The insert, if the value is already present, return false. Else insert if map dot contains key of value already present, just return false. Else, else what we need to do is set into list and map, right? So list dot add of list dot add of value, right? And I'm going to add into my map dot put value comma list dot size -1, right? Because I have took this because I'll be adding at the end of the list, right? So for this value the index is the it will be the last index, right? If you look at this, if I want to insert 5, initially my index is 0 1 2 3. It is till 3, right? So what I'll do is I'll insert at the end and this index will become 4, right? So my total, the size of the list is 5 and I'm reducing 1 and the index will become 4. So in my map I'll keep something like 5 is 2 at index 4. That's what I'm doing here. After that I'll just return true. Since I have successfully inserted the element, I have returned true and removing an element. If map dot contains key of value, if the element is not present, I'll just return false, right? If it is present, the element is present. Before that, let's try to solve this thing. Okay, what we need to do is right here. We just need to generate a random value I don't know how to generate a random value. Let's okay. You see that we just need to import the random class and we need to create the object of the random class and we need to give the length from if we are giving 50 we are having a random value from 0 to 49, right? So what we'll do is just import the random class, import util.random, and I'll just create the ran- random x equals to dot of will be of list dot size, right? When I give list dot size, it will produce a value between 0 and list dot size, right? So let's return dot get of random x. That's it. Here is the main important part. What we need to do is, because we have an element, we need to swap the elements. Suppose, suppose if we have something like 1, 2, 3, we need to remove an element 2. What I'll do is I'll ask the hash map to give me the index of this 2. So what I'll do is index equals to I'll ask the hash map give me the index of it, and what I'll do is I'll swap this thing with the last index, right? So what I'll do is I'll swap. How am I going to swap means last the last element equals dot get of. So what I did here is I just took the index of the current element, just took the index of the element that I'm removing, and I took the last element and I took the last element, and this is the current element. I took the 2. Then what I did was this dot set of index of last element. So what I'm doing is I'm just taking this 3 here. We don't need to take out 2 here because we're obviously removing that thing. So we don't need to swap 2 here. So we just need to remove 3, right? So I just at the end what I need to do is list dot size minus. What I did was I again changed the index of 3, index of the last element to the current index, and at last I'm returning true. Let's try to run this. Error. Come on. Let's try to submit this. Oh, wrong one. Wait, I'll be back. Oh, what's the problem here is when we are inserting, we need to get false, but I'm sorry, we need to return true, but we are returning false, right? This means we're actually not removing it from the map. Map dot of current element. Let's use this test case and let's try to run it. But again, the same thing. Wait. Okay, I understood what the problem is. Basically, what we're doing is initially we're giving 0 and we're removing it, and again we're having 0. And what I'm doing is, I'm copying this thing to another variable. I'm just swapping this thing with this thing, and after that, I'm just removing this thing and I'm appending this thing again. So when when map dot size equals to 1, I just need to remove map dot here, here, return true. So try to run, try to submit. Wait, guys, I just rearranged the instructions. I just took the x of the value to be removed, and I took the last element, and I set my current element to the last element. I just brought the last element to the index, and what I did was I also updated the map, and at the end I just removed the list, the element from the list, and the element from the map as well. It's working fine. Thank you guys.